IT painkiller. Remote monitoring and management, remote access, help desk and ticketing.
On your local network. We refer to this as a bridge network address. It performs a network address translation to be able to communicate outside the scope of that hypervisor. You can also configure a virtual machine to look and act as if it's any other device that's on your local network. You can configure your hypervisor with a private address so that virtual machine can only communicate with itself and any other devices that you decide. Security is always a concern when you're running so many different operating systems on one physical device. Fortunately, there have not been any significant security breaches relating to hypervisors, but this is something that hypervisor manufacturers and developers are always aware of. One type of security vulnerability that is top of mind for these hypervisor developers is a VM escape. This is when malware might find itself onto one virtual machine and use a flaw in the hypervisor to be able to communicate to other virtual machines that are supported by that same hypervisor. This would obviously be a As you're most likely aware, when you turn on your computer, there are a series of tests that take place known as the POST. This stands for Power On Self-Test. This is a self-test to determine if the core components of your system are installed and if they're operational. This checks to see if your CPU is installed and operational and if it's able to communicate to your BIOS hardware. This might also check to see if your video subsystem is working properly and if memory is also installed in your computer. If there are any problems with any of these components, you'll get an error message on the screen if possible and a series of beeps that come from the motherboard. The beeps and the messages that you might see on the screen might be similar between manufacturers, but very often there are differences between one manufacturer's BIOS and another. This means that a series of beeps on one motherboard might mean something completely different on another motherboard. For that reason, you shouldn't bother memorizing specific beep codes for an individual manufacturer, because when this happens, you'll probably be referencing the documentation anyway. And since all of these different manufacturers are using different beep codes on different motherboards, it's probably a good idea to check with the documentation anyway. The real key is understanding what that beep code means and what you should do next. And if you are getting beep codes, there should be messages on the screen if there's no problems with your video display. And certainly there will be a series of codes, probably long and short codes, that you'll need to reference. You'll need to look at the error codes on your screen and reference how many beeps you're hearing in this beep code against the manufacturer's documentation. That's going to tell you what part of this BIOS failed and hopefully point you in a direction for resolving this hardware problem. If you turn on your computer and start hearing beeping noises, but you see nothing on the screen, then your problem is probably related to bad video on the motherboard, although it could be related to bad memory or a bad CPU. If any of those components aren't working, then you probably have no way to present any data on your screen, and therefore the screen remains black. This could also be a misconfiguration with the video subsystem inside your BIOS, so you'll want to look at the BIOS configuration and confirm that everything in the BIOS looks to be in order. If you're powering up and you get a message that the BIOS time and date is incorrect, then it's very possible your problem is with the battery that's on the motherboard. One of the few reasons we still have a battery on the motherboard is to maintain the date and time, especially if there's no power source to the computer. This means we could move the computer, plug it back into a power source, and the computer already knows the date and time based on that clock that's keeping that updated when you're not connected to power. If your battery has failed, you'll be prompted to input the date and the time each time you plug in that computer and start it back up again. Simply replacing the battery on the motherboard will resolve this problem. You can put in the correct date and time, and you'll no longer be prompted each time you turn on your computer. And you may find when you start your computer that it tries to start an operating system from a USB key that you installed into the computer. This may not be the boot process you would like to have in place when the computer starts. So you might want to look at your BIOS and see what the boot order happens to be. For example, you may be able to set the USB connection at a lower priority than your internal SSD to ensure that that SSD drive is always referenced first during the boot process. You'll obviously need a valid operating system on whatever device you decide to boot from. So if it's an SSD or a flash drive, you'll need an operating system so that you can start from those individual storage devices. And your BIOS might give you the option to check that there is actually media plugged into that particular startup device. If there's nothing physically connected to those USB interfaces, then your BIOS will decide to go to the next device on its list of boot devices. When you're working on your computer, it's important to know what to do next when you run into a problem, because your issues might be bigger than you were expecting. Whenever you see an error like this, you know that the entire system has come to a stop. It might tell you that your device ran into a problem and now needs to restart. It also says it's collecting some error info, and then the system in many cases will automatically restart for you. This message is referred to as a Windows stop error, and it's the kind of message you see when the operating system is not able to recover from some type of issue. Sometimes you'll see people refer to this as the blue screen of death, because if you see this message, you will need to restart your computer. And if you haven't saved any of the documents that you were working on, then you'll probably have a lot of work to do when the system restarts. Although this is a message we really don't want to see on our screen, it's important to know that there may be some very important details contained within this blue screen. For example, there might be a specific driver name on this blue screen, or it may have a specific stop code that you can then reference on Microsoft's online site. The blue screen will give you some prompts to help lead you down the path of troubleshooting this problem. For example, it says, for more information about this, it's important to know that there may be some very important details contained within this blue screen. For example, there might be a specific driver name on this blue screen, or it may have a specific stop code that you can then reference on Microsoft's online site. The blue screen will give you some prompts to help lead you down the path of troubleshooting this problem. For example, it says, for more information about this issue and possible fixes, visit www.windows.com/stopcode. And there's also a stop code provided on the blue screen, which is 0x Charlie 0000135. That's the information that you would put into the Windows.com website, and it will provide you with information on where you can start with your troubleshooting efforts. If you do get one of these Microsoft blue screens of death or a BSOD, then your problem is probably related to something the operating system was not able to recover from, relating to bad hardware, bad drivers for the hardware, or a bad application itself. If this is something that just started after making a change or installing a new application, you might be able to use the option during startup to use the last known good configuration, run a system restore to move back to a particular date and time, or roll back the driver that you most recently installed. If you're getting this blue screen problem when you're starting your computer, you might want to try starting in safe mode to see if that can circumvent the issue. If you believe that this problem is related to the hardware on your computer, you may want to try taking out the adapter cards and reseating them, or removing the memory modules and putting those back just to make sure that everything has a good connection. And if you've checked everything else and you think this may be related to the hardware of your system, this might be a good idea to run a full hardware diagnostics. These are usually provided by the motherboard manufacturer or the hardware manufacturer of the components within your system, and the BIOS that you have on your computer itself may have built-in diagnostics that you can use. You usually have the option to choose exactly which components you'd like to test and whether the test should be quick or something that you might want to run overnight. The Windows blue screen is a well-known crash screen, but it's very specific to the Windows operating system. Applications running on that operating system may have their own crash screen to give you information about what happened with that application. Sometimes these error messages are very informational and tell you exactly what you can do to help resolve the problem. Other messages may not provide quite as much detail as you may have hoped. For example, an error message of error 47829 and in brackets 22573 and a message saying frame buffer not supported doesn't tell you exactly what may have caused this problem or where to go to help resolve it. You as the technician need to make sure that you document as much of this information as possible. And although you don't understand exactly what error 47829 happens to mean, the manufacturer of the application may know exactly what's causing this problem, so providing them with this level of detail may help resolve this problem even faster. One of the best things you can do is to get a screenshot or take a picture of the error so that you can provide that to the manufacturer. This gives them context about what you were doing on the screen, and it gives them more information about the error message itself. If you're working on a help desk, it might be useful to ask users proactively to add a screenshot as they're documenting the information for this ticket. To give you an idea of why it might be a good idea to get a screenshot or picture, I wanted to show you a couple of proprietary crash screens. Here's one that says, to run this application, you must first install one of the following versions of the framework, S000357.12.5567. I don't know either. Please report what caused this error along with the information below. Loader x86.cpp is not accessible. Another error message you might get, and this is one that's not uncommon, is one that simply says unknown error. Sometimes you're able to use this information to help troubleshoot. Other times all this really can provide you is a message that an error has occurred. But in both cases, there might be other details that you're able to gather from other log files or from the event viewer, and you should try to gather as much information as possible to provide to the application manufacturer. If the screen or external monitor of your computer is black and shows nothing on the screen, then you can go through a number of troubleshooting steps to help resolve this. If you're working with a technician, they may first ask, is the monitor connected? They want to know if the cable connecting that monitor is really connected to the interfaces on the monitor side and on the computer side. And not only should you check the HDMI, DisplayPort, or USB-C connection for this video, you should also check to see if the power cable is also connected. This is one of the most common reasons for a black screen, which is why it's the first thing we tend to ask. Many monitors can support input from different types of video interfaces. If you look at your monitor, it might have an HDMI interface, a DVI port, and a VGA interface all on the same monitor. So you need to make sure that the input selection of the monitor is pointing to the right interface that you're connected to. If you are plugging in with an HDMI cable, but your monitor thinks it should be looking for the signal on a VGA connection, then you obviously will see a black screen on the monitor. This might be a situation where you're able to see the information on the monitor, but it's very dim and difficult to see. In that case, you may want to check the internal configuration settings of the monitor itself, because there are brightness and contrast controls built into the monitor settings. This might require a number of buttons to press on the monitor, so check with the monitor documentation to see exactly what the process would be to check for the brightness. If you've done this troubleshooting and you still aren't able to get anything on the screen, you may be thinking that the monitor itself could be bad. One way to check that would be obviously to swap this monitor out for one that is a known good monitor and see if you're able to see any information on the display. If you're still seeing a black screen, then your problem is probably not with the monitor hardware. And if you find that you're able to see information on the screen during the boot process, but as soon as Windows starts, you get a black screen, this might be related to the video configuration inside of the Windows operating system. One way to start your Windows configuration with a generic video driver is to use VGA mode. You access that mode by using the F8 key during the boot process and choosing VGA mode as your boot option. To be able to use these computers, we need some type of power source. And if we don't have a power source, our computer is not going to operate properly. But the question is going to be, why are we not getting power to the motherboard, to the video configuration inside of the Windows operating system, if you're able to see any information on the display? If you're still seeing a black screen, then your problem is probably not with the monitor hardware. And if you find that you're able to see information on the screen during the boot process, but as soon as Windows starts, you get a black screen, this might be related to the video configuration inside of the Windows operating system. One way to start your Windows configuration with a generic video driver is to use VGA mode. You access that mode by using the F8 key during the boot process and choosing VGA mode as your boot option. To be able to use these computers, we need some configuration. But as soon as Windows starts, you get a black screen. This might be related to the video configuration inside of the Windows operating system. One way to start your Windows configuration with a generic video driver is to use VGA mode. You access that mode by using the F8 key during the boot process and choosing VGA mode as your boot option. To be able to use these computers, we need some type of power source. And if we don't have a power source, our computer is not going to operate properly. But the question is going to be, why are we not getting power to the motherboard of this computer? Is the problem in the outlet on the wall? Is the problem with the power cord itself? Or is the problem with the power supply of your computer? You'll need to check a number of different components to see where the power is and where the power might not be. One of the best ways to do this is with a multimeter to be able to check not just the AC power that's in the outlet, but the DC power that's coming from the other side of your computer's power supply. You might also find that some components within the computer are working properly, but other components aren't working at all. For example, you may find that your fans are spinning in your computer case, but there's no other power or lights on any of the other devices inside of your computer. You may want to trace back the devices that are working to see where they're connected. Are they connected directly to your power supply, or do they connect to power sources on the motherboard itself? If the fans are spinning but we're getting no video when we start up, then it's probably a post error, which means your motherboard itself could be bad or the video card of your device could be bad. And if the problem is that only your fans are working, it might be an issue with the voltage that's being sent out of your power supply. The fans themselves don't need a lot of voltage. The voltage that's being And if the problem is that only your fans are working, it might be an issue with the voltage that's being sent out of your power supply. The fans themselves don't need a lot of voltage, but obviously the components on your motherboard need a lot more power. So you may want to grab your multimeter and check all of the different voltage outputs on your power supply to see if all of those are working properly. One of the more frustrating problems to troubleshoot is one where the computer is slow. If you're starting to get sluggish performance from your operating system, the problem could be almost anywhere on that system. So one of the first things you'll want to check is your task manager. This will show you how much CPU, memory, disk, network, and other metrics are associated with different processes in your operating system. You might find that certain applications have a high amount of CPU utilization, or there's a lot of information being transferred in and out of a particular application. The Performance tab can give you a graphical view of this over time, so you can see in the last 60 seconds how much CPU have we used on this system, how much memory has been available, and how much networking communication has taken place. This might help you narrow down where some of the more intense resource utilizations are occurring, and it might resolve the problem of any type of sluggish performance. If the problem seems to be more generic and not specifically associated with an application, you might want to make sure that your operating system is up to date. So run a Windows update and make sure that all of the latest patches and all of the latest drivers are installed. We almost forget how much information our operating system reads and writes to our storage drives. And if we run out of space on a storage drive, we'll find that our operating system is not able to work optimally. So check your disk space and make sure that you have available space. And if you're on a hard drive, you might want to consider running a defrag. If you have a laptop, you might be familiar with the power saving modes associated with those laptop technologies. Very often, a laptop will automatically throttle down the CPU when you're not directly connected to a power source in order to conserve the amount of battery. But this might also cause a performance problem, especially if you have an application that wants to use as much CPU as possible. In that scenario, you may want to see if there's options to change the power saving mode or disable it, or you may need to connect to a power source to get the best possible performance. And if you're still trying to narrow down where the problem might be, you might want to run an antivirus or an anti-malware scan just to make sure there's no malicious software that may be executing in your operating system. Our computers create a lot of heat, and it's coming from different places inside of your computer. The CPUs are creating heat. Very often they have their own heat sink because they're getting so hot. We have video adapters that often create a great deal of heat in desktop and laptop computers, and even the memory modules put off a great deal of heat. To be able to cool down these systems and maintain the temperature inside of your laptops and computer cases, we have a number of cooling systems that we employ. One common cooling method is using fans so that we're pulling in cool air to be able to cool the internal components, and we're putting hot air out the other side of the device. We very often will use heat sinks on top of these very hot components to help dissipate that heat even easier. And you want to be sure that the fans are clean and that there's no obstructions inside of your computer to limit how much air you can pull through that system. If the fans and cooling systems inside of your computer are full of dust, it's not going to be able to cool anything in your system. The system will automatically start decreasing the CPU usage, and the system overall will have very sluggish performance. There are many sensors inside of your computer, and we can monitor those sensors with software. Sometimes this software is provided by the manufacturer of your computer, and there are also third-party choices as well. One piece of software I use on my computer is HW Monitor. You can find that at cpuid.com, and it is able to provide you with extensive detail about all of these different sensors inside of your laptop or computer case. Here's an image of a computer case that is not very uncommon. These computers sit under desks for long periods of time, and very often no preventive maintenance is ever done until you run into a problem. So if you're running into a problem with heat, make sure you check all of the fans and any other part of this computer where the airflow may be restricted. When electronic components fail, the failure can sometimes be spectacular. It's not unusual to see smoke and even smell that something is burning inside of your computer case. If this happens to your computer, you want to be sure to remove any power source from your computer as soon as possible to limit the scope of any damage associated with this problem. Once the smoke is cleared, you can remove the case cover, have a look at the motherboard and other components inside of your system, and see if you can visually find where this particular problem occurred. Often it's something that's very easy to see, but if you're not able to visually see it, you may be able to smell where on that motherboard you're having a problem. You obviously want to determine if it's part of the motherboard that's damaged or an individual component and swap that component or motherboard out to be able to get this system back up and running again. Another challenging issue is when a system randomly turns off. There's no messages on the screen, there's no warnings, everything simply goes black. The fans usually find where preventive maintenance is ever done until when electronic components fail, the failure can sometimes be spectacular. It's not unusual to see smoke and even smell that something is burning inside of your computer case. If this happens to your computer, you want to be sure to remove any power source from your computer as soon as possible to limit the scope of any damage associated with this problem. Once the smoke is cleared, you can remove the case cover, have a look at the motherboard and other components inside of your system, and see if you can visually find where this particular problem occurred. Often it's something that's very easy to see, but if you're not able to visually see it, you may be able to smell where on that motherboard you're having a problem. You obviously want to determine if it's part of the motherboard that's damaged or an individual component and swap that component or motherboard out to be able to get this system back up and running again. Another challenging issue is when a system randomly turns off. There's no messages on the screen, there's no warnings, everything simply goes black, the fans spin down, and you're left with a system that's no longer operating. After checking the hardware itself, you may want to try starting the system back up again, and if possible, check Event Viewer and see if any messages were written to the event log before the system powered down. Problems like this are very commonly associated to heat-related issues. Those sensors inside of your computer know exactly what the temperature is of your CPU, your storage devices, your memory, and other parts of your motherboard. And if the temperature of any of those components gets too high, your system will automatically power down to make sure that there's no damage to the hardware. Make sure you check that all your fans are clear and that you have plenty of airflow going through your system. Also check to make sure that the heat sinks on your different components are still connected. And if they are connected, you want to be sure that they have the proper amount of thermal paste. This is another good time to check your software to see what the temperatures might be in your system to see if this is really the issue that might be causing the system to turn off. This could also be related to failing hardware in the system, especially if you just added some new components. So check Device Manager on your system and see if anything may have been disabled, and you may want to run a hardware diagnostic just to make sure that there's no problems with anything you may have installed. Since this is something that's relatively random, it may be very difficult to troubleshoot. But if you start eliminating things that you know to be working properly, you'll slowly get down to a smaller list of where the problem may be occurring. There are a number of troubleshooting resources available for you in the operating system when you run into an application error. Some of these applications will simply stop working. They'll pop up a message on the screen like this one that says Windows Explorer has stopped working. And it may do some work to try to determine how you might be able to resolve this problem, or you may find that the application itself is on the screen and working properly one moment and then immediately simply disappears from your screen. Or you may find that the application is working fine one moment, but then abruptly disappears from your screen with no error message at all. One of the best places to go to gather more information would be Windows Event Viewer, or there might be specific logs for that application. You might want to check with the application developer to see if they have a series of logs they can either refer to or logs that we can turn on for any subsequent problems. Windows also includes a tool called the Reliability Monitor. This will give you a history of all applications that have occurred over time, so you can see what applications have been performing well and what applications give constant errors. This also is a nice integration into the event viewer, so if you're trying to filter down information very quickly, you may find it very easy to do from the Reliability Monitor. And of course, the application version of Have You Turned It Off and Back On Again is to simply uninstall the application and reinstall it again. This ensures you're using the latest version of the application and that you've installed all of the components of that application without any type of error messages. If you continue to have the problem, then the issue is probably not related to the installation of the application. Here's a better view of the reliability monitor. This is one of the hidden gems within Microsoft Windows, especially if you're trying to troubleshoot an application. You can see the applications that have crashed. You can see whether the crash itself was an application failure, a Windows failure, a miscellaneous failure, a warning, or simply an informational message of that application without any type of monitor. This will give you a history of all applications that have occurred over time, so you can see what applications have been performing well and what applications give constant errors. This also is a nice integration into the event viewer, so if you're trying to filter down information very quickly, you may find it very easy to do from the reliability monitor. And of course, the application version of Have You Turned It Off and Back On Again is to simply uninstall the application and reinstall it again. This ensures you're using the latest version of the application and that you've installed all of the components of that application without any type of error messages. If you continue to have the problem, then the issue is probably not related to the installation of the application. Here's a better view of the reliability monitor. This is one of the hidden gems within Microsoft Windows, especially if you're trying to troubleshoot an application. You can see the applications that have crashed. You can see whether the crash itself was an application failure, a Windows failure, a miscellaneous failure, a warning, or simply an informational message. All of these messages are documented in the details, and you can see the exact date and time when this problem occurred. If you turn on your computer and you hear some grinding noises, then you know something is probably going wrong. Most computers are either very quiet or have a small hum associated with them, so hearing any type of unusual noise should automatically make you think that something's not performing as it should. If you hear rattling noises when you're moving the case, then something has probably come loose inside of the computer itself. Very often this is a heatsink, and you can simply reinstall the heatsink with some thermal paste. If we're hearing a scraping noise, then our problem may be related to a hard drive. Those hard drives are obviously moving devices that are spinning at great speeds, and if there's any type of physical problem with the drive, those components will tend to scrape against each other. If the sound you hear is more of a methodical clicking noise, then there's probably something that's gotten in the pathway of your fan. This may be something where you need to check the fan itself to see if the fan is operating properly, or perhaps it's time to clean all of the dust and debris out from your computer so that your fan can spin properly. And if you hear a popping noise and you see or you smell smoke, your problem might be with a capacitor. The capacitors are located on the motherboard, and you may find that a capacitor looks fine with a flat top. There's no problems with this one, although right next door you can see there's a little bit of bulging on the top of that capacitor. Here's a view of some other capacitors. You can see the difference between a capacitor that may be flat on the top and one that might be bulging just a little bit. In extreme cases, this entire capacitor could blow, and you may have pieces of the capacitor that are now located in different parts of your computer. A blown capacitor might be a more difficult problem to resolve because you almost always need to replace the hardware. We talked earlier about starting your computer and having it prompt for a date and time. That's because the battery that's on your motherboard has failed, and you'll need to replace that battery so your system can properly maintain the date and the time. These are usually button-style batteries. They have a very low profile on your motherboard, so they don't take up a lot of room. They are usually very easy to remove and replace, and you can generally find these at most stores. If you have an older computer, you may find that removing this battery completely resets your BIOS configuration. On most modern computers, however, removing this battery will not change any of the configurations of your BIOS, including any passwords that have been set in the BIOS. If you need to remove or completely reset your BIOS settings, then you'll probably need to use a jumper to be able to do that rather than removing this battery. If you're working on your computer and you get a message that says cannot read from the source disk, or an error message that's very similar to this, then our problem is that we're either not able to write to the storage drive or read the information that has already been stored on the storage drive. When this occurs, you'll often see the drive constantly retrying that particular area to see if it can finally read the information that's stored either on the platters of the hard drive or the SSD. This type of failure could affect only a certain area of the storage drive, or it may be an intermittent type problem. Whenever it's occurring, you'll notice that the performance of reading and writing from the drive becomes very slow, because if the drive ever runs into this error, it will constantly try to retry the read or the write to that particular area of the drive. That retry takes time as it tries over and over to try to either read that data or write information into that area of the drive. Sometimes this is a loud clicking noise, especially if it's a hard drive that we're trying to access. Sometimes you'll hear people refer to this as the click of death, because once your hard drive starts making these clicking noises, it's very difficult to recover any of that data. These hard drives have platters inside that are spinning very rapidly, often at 5,400 revolutions per minute and higher. There are also these actuator arms that have heads on the end that are moving back and forth across those platters, and those can also have physical failures. All of these components have very high tolerances, and if any one of them happens to fail, it often creates a cascade effect with all of the other parts of the spinning drive. You'll also notice that a lot of these components are metal, so when you do start to have a failure, you'll start to hear clicking noises or grinding noises or the sounds of metal on metal. This may result in getting very poor performance as the drive continuously tries to retry writing or reading to that drive, or you may get an error message on the screen and no access at all. Once you start having a physical problem with the storage drive, it can be very difficult to recover from that particular problem. This is one of the reasons that we always tell you to make sure that you have a very good and recent backup of everything that's on your system. If you do start to hear these noises and you haven't gotten a recent backup, this is your cue to stop what you're doing, get a backup system, and back up as much data as possible from that storage drive. From that point, we can start doing a little more troubleshooting. We might want to check for any loose or damaged cables if this happens to be a desktop system. This might be an easy fix where we simply reseat a cable and we're able to communicate properly to that drive. We should always be aware of any heat problems inside of our computer case, and it could be that our storage drive is getting too hot to operate properly. You might want to check your monitoring software on your computer to see what type of temperatures we have inside of your case and on the storage drive. If we've recently added new hardware to our computer, we could have a problem with how much power is being provided by the power supply. So you might want to perform an audit of all of the components in your system and calculate how much power they'll need, and then compare that to the capabilities of your existing power supply. If the drive is still working, you may want to go to the manufacturer's website and download a set of their recommended diagnostics. This is a test that you would commonly run overnight, and you would try reading and writing to every single sector on that particular drive. This would give you an idea of whether the problem is isolated to a small area of the drive or if it is a much widespread problem with that particular storage device. When you boot your system with a bad drive, you may see messages like drive not recognized or boot device not found. Sometimes there will be lights showing you when access to the drive is being attempted, or if you're seeing no lights on your system, it could be that the drive is completely unresponsive. These error messages will often be accompanied by beeps to let you know that an error has occurred, and if you are getting video on your screen, you may also have an error message that has more detail. If you get a message that an operating system was not found, that means that the drive is available and the system is able to access that drive, but it's looked through the file system on that drive and is not able to find any available bootable operating system. If our message is that we're not seeing any drive at all and we're not seeing any, if you get a message that an operating system was not found, that means that the drive is available and the system is able to access that drive, but it's looked through the file system on that drive and is not able to find any available bootable operating system. If our message is that we're not seeing any drive at all and we're not seeing any access lights on the front of our computer, then it could be that we have a bad cable connection. You'll want to try reseating the power and the data connectors for your storage drive and see if it's able to see the drive after a reboot. Also check the boot configurations in your BIOS. You want to be sure that the boot sequence is what you would expect. And you want to be sure that your BIOS is not configured to look at any removable storage devices to be able to boot from those. If you have a USB flash plugged into an interface, your system may be trying to boot from the USB drive instead of your SSD. And if this is a brand new storage drive that you're using for the very first time, you may want to double check your cables, make sure it's getting the proper amount of power, and that you're accessing that drive properly from your system BIOS. If you have any known good cables that you could swap out for the cables you're currently using, it would be a good way to easily check to see if your problem is simply related to the cable connection instead of the storage drive itself. And if you think the problem is with your motherboard or the SATA interfaces on your, if you have any known good cables that you could swap. And if this is a brand new storage drive that you're using for the very first time, you may want to double check your cables, make sure it's getting the proper amount of power, and that you're accessing that drive properly from your system BIOS. If you have any known good cables that you could swap out for the cables you're currently using, it would be a good way to easily check to see if your problem is simply related to the cable connection instead of the storage drive itself. And if you think the problem is with your motherboard or the SATA interfaces on your system, you might want to remove that drive, move it to a different computer, and see if you see the same problem occurring on that separate system. As we mentioned earlier, these hard drives are mechanical devices. And because of that, the question is not if your hard drive is going to fail, but when is your hard drive going to fail? If your drive has failed and you need data off of that drive, sending it to a drive recovery service is expensive and time-consuming. If this is an SSD that has failed, you may find that you're not able to write to that SSD, but you are often able to read the data from that SSD. In all of these cases, the data that's on the storage device could be corrupted, or it may simply be unavailable and inaccessible going forward. This might even be difficult, if not impossible, to recover depending on the type of problem. This is why we always tell you, have a backup of your data. Having a backup can solve all of these problems for you, and you may be able to recover the data in a relatively short period of time. If you're working with a server, you probably have more than one drive inside of that server, and very often we've configured those drives as a RAID array. That is a redundant array of inexpensive disks. Any one of the drives that happen to be in that array could potentially fail. It could be that the drive itself has failed. Maybe the drive is not receiving enough power. And that's the reason we can't communicate to it. Or it may not be connected properly or might have a bad cable, and that might cause a communications issue. Most RAID arrays will give you detailed information about what's happening with that array, especially if there's an error. So check any error messages on the screen or any email notifications that might have been sent from your RAID controller. And very often there will be audible alarms to let you know that something about these drives is not working as expected. One of the challenges when troubleshooting these arrays is that there are often many drives to choose from. So when you're troubleshooting problems with a RAID array, make sure that you are focusing on the correct physical drive that is experiencing these issues. There's often extensive information you can gather directly from the RAID controller. It will tell you which volumes are healthy, which volumes may have a drive that has failed. This one says that one or more storage pool SSD caches are degraded. We recommend replacing the failing drives with healthy ones. Here's a RAID array with 12 physical drives, and almost all of these drives are identical to each other. So if you are replacing one of the drives in this array, you want to be sure that you really are replacing the bad drive and not accidentally replacing a good drive. When you're working with a RAID array that has failed, it's important to know what type of RAID you're using. This RAID type will help you understand how to reconstruct this array once you replace the bad drives. If you're running RAID 0 or striping, you need at least 2 drives. Since this is RAID 0, there is zero redundancy. So if there is a single drive failure, the entire array is broken and you have lost data. The only way to recover that data is to restore from a backup once you've replaced the bad drive. RAID 1, or mirroring, also requires a minimum of 2 drives, and as long as only one drive has failed, the array will continue to work normally. Your end users probably won't even know there's a problem. You simply need to replace the bad drive, and the RAID array will rebuild itself with the information that still exists. RAID 5 is striping, with the equivalent of one drive being parity. To be able to use RAID 5, you need at least 3 physical storage drives, and all but one of those drives needs to be operational. When you lose one drive from a RAID 5 array, your array will still continue to operate. The users will still have access to their data, and when you replace that drive, you can resynchronize the array to get 100% back up and running. RAID 6 is also striping, but it includes the equivalent of 2 separate parity drives. That means that we need at least 4 drives to be able to have a RAID 6 array. And since we have the equivalent of 2 parity drives, we can lose 2 individual drives in that array and still be up and running. Just as we did with RAID 5, we can replace the bad drives, resynchronize the array, and have everything back the way it was prior to the failure. With RAID 10, or RAID 1 plus 0, we are performing a striping and a mirroring of those stripes at the same time. That means that we need at least 4 drives to be able to use RAID 10, and if we lose one of those striped drives, we're still up and running because we are also mirroring those striped drives. That means that we could potentially lose 1 drive from each of those mirrors and still be up and running. So RAID 10 allows us to lose everything but 1 drive from a mirrored set of stripes. Most of the drives we use these days have technology inside that keeps track of many different statistics regarding the performance of that drive. We refer to these statistics as SMART. This is the self-monitoring, analysis, and reporting technology. This often uses third-party utilities to grab these SMART statistics and provide you with a detail of how that drive may be performing. You could use a third-party tool that provides you with a breakdown of the statistics similar to what you see on the screen here. This is the raw data directly from the SMART statistics on the drive. You would need to know which one of these statistics to see, such as power on hours, power cycle count, temperature Celsius, and other metrics. You might instead want to use third-party software that analyzes all of this data and then provides you with an analysis of whether the drive is performing well or if there are problems. This third-party software may be able to provide this analysis over time, so it can perform daily checks, weekly checks, or monthly checks to give you an idea of how this drive is performing over time. And if you start to see certain statistics degrading over time, you might be able to replace this drive before it fails completely. Using these SMART statistics can give you a good idea of the warning signs and allow you to prevent the drive from having any type of catastrophic failure. Very often, a RAID array will have this functionality built in, but you can also have third-party software on your laptop or portable system that only has a single drive inside of it. You can receive messages on your screen that tell you how the performance of these drives happens to be, and many RAID arrays can send email messages or text messages so that you can get this information even if you're not in the console or looking at the console in the data center. This might be your warning to take an extra backup of the data that's in that array, and you might also want to proactively replace any drives that are showing any type of errors. Our storage drives are a significant component inside of our computer, and they have a dramatic impact on the overall performance of our system. That's because these drives are sending and receiving information from memory. There's communication across the bus to be able to communicate to that device. If it's a hard drive, there's the spinning drive access that adds additional delay. And of course, you could be reading or writing large amounts of data to this storage drive or only a little bit of data. All of these different processes combine to create additional slowdowns or delay in accessing your data. And any problem with any of these steps could create significant delay. There might also be times when we'd like to compare the performance of one storage drive versus another. So you might want to perform some performance checks to see if you could tell which drive would really be the better choice. One of the metrics that we use to provide that type of feedback is the number of input-output operations per second, or IOPS. This is a very broad view of performance, and it gives you an idea of the receiving information to take an extra backup of the data that's in that array, and you might also want to proactively replace any drives that are showing any type of errors. Our storage drives are a significant component inside of our computer, and they have a dramatic impact on the overall performance of our system. That's because these drives are sending and receiving information from memory. There's communication across the bus to be able to communicate to that device. If it's a hard drive, there's the spinning drive access that adds additional delay. And of course, you could be reading or writing large amounts of data to this storage drive or only a little bit of data. All of these different processes combine to create additional slowdowns or delay in accessing your data. And any problem with any of these steps could create significant delay. There might also be times when we'd like to compare the performance of one storage drive versus another. So you might want to perform some performance checks to see if you could tell which drive would really be the better choice. One of the metrics that we use to provide that type of feedback is the number of input-output operations per second, or IOPS. This is a very broad view of performance, and it gives you an idea of the overall capabilities of any particular storage device. To give you an idea of just how important these values are, let's compare a hard drive with an SSD. The number of input operations per second of a hard drive is approximately 200. That's the maximum number of operations you would see for one of these spinning drives. But if you replace that hard drive with an SSD, a solid state drive, your IOPS goes up to approximately 1 million. That is a significant difference between the spinning hard drive, and very often we tell people to simply replace their hard drive with an SSD and they've immediately upgraded their system. If you boot your system and you notice that certain drives are no longer accessible from your operating system, it may be that those have been disabled in your BIOS or there was some type of error with your BIOS. You may want to check your BIOS logs or the BIOS configuration to see if your system is really seeing those drives as being accessible. If this is an internal drive, it may just be a loose cable or something that may have been disconnected, so simply reseating those cables will usually solve that problem. If it's an external drive, then you want to check all the cables going to that particular drive, and you may want to check the drive is receiving power through the power connection. In some cases, a user may boot their computer, but the drive that's missing is not a physical drive on their computer, but a drive that they would normally map across the network. This is done usually during a login process or a login script, or it may be something the user can do manually. You might want to look at your operating system and see what the status is for map drives across the network. This is the map network drive for Windows, where you can select what drive letter you would like to use, the folder, which in this case is pointing to a server called Gate Room, and the share on that server is called Mission Reports, and you might even want to make sure that the checkmark says that it will reconnect at sign-in, so the next time this person boots their machine, this drive letter will automatically connect across the network to the Gate Room server and the Mission Reports share. We've been talking during this video about the drives that go bad, but we could have cases where the drive controller is going bad. We often see this if we're using an external drive controller, which we often do when we're configuring a RAID array. When you boot your system, you might see messages like this one. This one's booting up and telling you what different function keys you can press. It tells you the type of processor you're running, how much memory is in the system. There is a boot agent for the Ethernet device because you could boot across the network. And then we come to the section that tells us about the drive controller. It tells us that we have a Dell PERC H200 6 gigabit SAS HBA BIOS, and that is related to the drive controller in this Dell server. This says there is an integrated RAID exception detected and that a volume is currently in the state of inactive and optimal. So you would need to go into the configuration utility to provide more investigation about why that controller is having a problem or why the drive connected to the controller is having a problem. To provide more investigation, and that is related to the drive controller in this Dell server. This says there is an integrated RAID exception detected and that a volume is currently in the state of inactive and optimal. So you would need to go into the configuration utility to provide more investigation about why that controller is having a problem or why the drive connected to the controller is having a problem. If you've ever turned on your computer